Right, good afternoon or good evening. I'm not quite sure what 5 o'clock equates to in Kendal time. Welcome to Kendal Mountain Festival, and in particular welcome to Kendal Mountain Book Festival. It's fabulous to see yet again another sold-out session within the festival. It's brilliant to see so many people here. And of course, I'd like to just thank Cotswold Outdoors, the sponsor of all of the book festival, for helping us put all of this together. Probably many of you will have been slightly disquieted by that rumbling sound that was taking place in the background as you were coming in. I'll invite Clive to explain what you were listening to in a few moments. But before we begin, I just want to let you know that there'll be a book signing after this. So at the back of the room, after we've given the talk, we'll be moving on to a book signing. The intention will be Clive and I will talk for about 3/4 of an hour and then open up the floor to questions. And just in terms of housekeeping, it would be very grateful if you could make sure that your mobile phones are on silent or switched off, please, if possible. Could you also note that there are fire exits around the room? They should be lit up. I can't see them because the spotlights are on me. But if there are plenty of volunteers in the room to help us with finding where we need to get out if a fire alarm goes off. So, my name's Simon Carr. I'm Associate Professor here at the University of Cumbria, based up in Ambleside, where we have all of our environmental programmes. And it's been an absolute delight to be here to interview Clive Oppenheimer about this book. I don't know how many people have actually already got the book, 'cause it's been out for a little while now. You see a few hands that are sort of waving in there. Well, hopefully by the end of this session, you'll all absolutely want to pick up this book and read it, because it's wonderful. We've all, I'm sure, drawn volcanoes as children or as adults, or we've seen our own children draw them. They hold an immense fascination, and I think this book is a really wonderful opportunity for us to explore that a bit. So it's an absolute delight to have Clive Oppenheimer, Professor Clive Oppenheimer of Cambridge University, here with us. I'm sure for many of you, you don't need an introduction to Clive. He's one of the world's leading volcanologists. He's got over 350 papers that he's author or co-author on in terms of primary research, which that equates to roughly about 10 a year, if you're thinking about these sorts of things. I think you've also supervised or advised over 50 PhDs in the fields of volcanology and the application of volcanology. But one of the things that I love as an academic myself is the way that Clive is someone who has now looked out beyond purely the academy, looking at how we can engage the public audiences with the love of the subjects that we all get to study within our professions. And of course, many of you will have seen the films that Clive has been producing with the filmmaker Werner Herzog, but also TV and radio work that he's done, particularly with the BBC, and of course, now this book. So welcome to you, Clive. Very pleased to have you here.
I'm very happy to be here. Thanks so much, Simon, for the introduction. I'm not sure I'll get my head out of the door afterwards.
So, there's so much that we can talk about within this book. It covers so many bits of ground, but I think before we go any further, I'd sort of would invite you to just explain to the audience what those somewhat disquieting sounds were as everybody was coming in and settling down. It wasn't everybody upstairs for us.
Yes, I'm sorry if that was unnerving or unsettling for anyone. It was a soundtrack I made for a short film for an exhibition at the University Museum in Cambridge. At a museum true to nature, landscape art from 1780 to 1850. And I was invited to contribute some rocks to it, and I said, well, I can probably stitch a film together for you with some of the footage I've taken on field work, and I thought, well, it needed a soundtrack. So those were some of the natural sounds from volcanoes, but also there were some infrasound and seismic records that have been made audible. And it's kind of multi-tracked, so things are going in and out. There's a bit of lava seeping around your ankles as well at one point.
Just to make the room feel a little bit warmer already. I think it's really hard, when we look through a book like this, there's a lot of imagery within the book. There's at the start of every chapter, there's a lithograph that kind of is quite often quite a whimsical image within there. And then there's, in the middle of the book, there's about sort of 10 pages of colour images. But I can imagine it must have been really quite difficult to select just a very, very small number of images within there.
Yeah, I don't know if I spent as much time as selecting the images as writing, doing the writing, but the lithographs were quite important to me because I thought they, each one could tell the story in a slightly different way of what was coming up, or just something that would make you laugh and then take you into an adventure. The photographs, as you say, I think it's 8. I don't know. They come in books of 8 leaves or something. Yeah. So I thought initially, well, I want to maximise the impact. I'll get some portrait aspect images, just one on each side, and then of course, like how do I sift through all my favourite volcanoes? And so then I started to divide up, and there are smaller pictures. But yeah, they went through a few iterations, and each one, each side has a sort of thematic to it as well. And the publisher said, you need some pictures of you in there. So I dug out a few of the scenes of me after I'd been volcanoed.
I was going to say, there's a few of you looking very weathered, to say the least, in there. But you've written, extensively as an academic in the research. But as you say, you've been on this sort of journey over the last 15 years or so. And I think there was the Eruptions That Shook the World book, which was sort of a bit of a crossover between the academic and the non-academic world. But this book, Mountains of Fire, it feels very much that this is the first book that is explicitly for a public audience. It's really directed to that wider reader. What was your motivation in putting the book together? And in terms of the timescale, why now? Why did you decide to publish something now?
The initiative came from Hodder and Stoughton and my editor Anna Beatty. She wrote to me out of the blue very early in the first lockdown, and I'm struggling to figure out that homeschooling is an oxymoron. And I received this email, have you thought about writing a book? And I thought, well, okay, let's have a think. And I thought, well, I'm going to be grounded probably here for some time now with this pandemic. Maybe now is the time. I think the timing was right because of that. The timing was right as well because I'd made 2 films, and it meant that I thought actually very differently. I thought in terms, I guess, more of the visual language of the book and the storytelling and how it might fit together. And then I guess there were a couple of other things. One I wanted it, I realized it was, volcanoes were going to be in it and some of my adventures and some characters, but actually I realized that it was going to be a book about listening. A book about listening to experts, listening to citizens, listening to tribal leaders and elders who live on the sides of volcanoes and have different knowledges to what I've had as a geoscientist. So those were some of the motivations, and I also wanted, I guess, a bit of a love letter to volcanoes and appeal to observation and empiricism. And that came about because at that time there was a lot of talk about models. Yes. And what was this pandemic going to do, and it might do this, it might do that, but there wasn't any testing. So what were these models grounded in? They weren't grounded in any data, and data and observations and making careful observations is sort of at the center of my professional career. So I wanted to kind of talk about that tradition of empiricism.
And I think following on from that tradition, it's that observation of the world around you. Who's sort of inspired you into that? Because I know you had people like Peter Francis when you were doing your PhDs. I remember reading his book on volcanoes. I think you co-wrote the second edition of it together, didn't you? But that was very much about the importance of observation within there. How has he sort of shaped your thinking over the decades?
So Peter was a huge influence on me, but I would say my observational life goes much earlier. I mean, probably 8, 9. I grew up in London, so I wasn't exactly surrounded by geological wonders like you are here. but there was a geological museum which I loved, and the rocks and minerals and the fossils and radioactive stone with a Geiger counter going off, and all this kind of thing. But also just hedgerows, hedgerows and ladybirds and butterflies. And so I was an observer, and I think that's sort of part of the motif. I got the geology bug at the Geological Museum. I was headed for a geology degree, And before I went to study at university, I traveled in Indonesia, and I had a book called Volcanoes by Peter Francis. And Peter was a great communicator. He wrote that book, I think, originally in 1979, the year before Mount St. Helens exploded in the Pacific Northwest. And it was the book, immediately people turned to this. They wanted to know what volcanoes were and how they worked. And I was reading Peter's book and looking at the illustrations and looking at the landscape around me and thinking, oh, this looks just like this volcano here, and the way it's eroded is how he's just described it in this schematic. Yeah. And little did I know that 5 years later, Peter would be my PhD advisor.
It's funny how those things happen, isn't it? And certainly, returning to the book itself, as you read the book, it's organised in a series of chapters which are largely based around a single volcano or a single group of volcanoes. And that's one of the threads through the whole of the book, is this love of the volcanoes and the processes that are operating, and often the hazards that are associated with that. But it feels like it's a book that goes into far more. And as you were saying, it's that historical context. There's a lot of what you talk about within the book is about the cultural significance of the volcanoes that you're working upon. And then also the lovely stories of of your own experience. I think there's some very honest narratives there about your own experiences and naivety. And I think some of your experience early on Stromboli was quite eye-opening. But also of the people that have sort of gone before you, the people that have really shaped the discipline of volcanology. But I suppose the big theme that really came out for me reading the book is that volcanoes are something both to fear and revere as well. And there's that real sense right the way through the book of the spirituality of a lot of these locations just because of their setting. But the question I wanted to ask is, that most of the volcanoes that you talk about within the book are ones that are probably less well known. There's a few, Stromboli and Vesuvius that you talk about, and there's some of the ones in the Caribbean which are familiar to many, but a lot of them are ones that I think nobody has ever heard of. For example, the volcanoes in the Tibesti Mountains in central Sahara. I didn't even realise that there are volcanoes in the middle of North Africa for a start. So what was the basis for you choosing which volcanoes, which stories to tell when you put the book together?
So I decided quite early that I would structure it geographically. I could have done it by themes of hazards and climate impacts and so on, but I plumped for geography, and then it was the places that I had stories to tell, and the volcanoes that I'd worked on the most, or had revealed the most interesting science, or had backstories. Yeah. And that very quickly came together. Yes. And it led me into a little bit of tricky waters, because as I wrote, I picked the low-hanging fruit. Started with Stromboli. It took me a month to write a chapter, and bit by bit I was leaving the more and more complex narratives towards the end. So it was a bit of a struggle.
Because there's quite a lot of sort of themes that sort of come in and out of each chapter, because each chapter reads on its own quite easily. You can just read that and pick it up and go, I've learned something about the volcanoes in Java, for example. But there are these threads, and particularly I think it's some of the characters that you've worked with in terms of these figures right the way from the 14th, 15th century, right the way through to the present day, that have really shaped our understanding. Because although the volcanoes are the stars, I think in many ways those historical figures, and some of them are still alive, really sort of chart that development of the subject. So you talk very early on about Oviedo, it's sort of at the time of Columbus, seeing giving us the term volcano for the first time. I hadn't realised that it was as recent as the 15th century to actually have the term volcano. What were they called before that? How were they referred to?
They were called burning mountains or smoking mountains. Even the Romans didn't have a word for volcano, even though there are plenty of volcanoes in Italy. Yes. So it's thought that it came from the time of the Spanish conquest and the conquistadors are in Central America, Mesoamerica, and they saw one volcano after another. And they got fed up of saying burning mountain, burning mountain. many of them were sailors, and they knew Volcano, the island in the Mediterranean in between Sicily and the boot of Italy, which is a smoking mountain, an active volcano. And Volcano became volcan in Spanish, and that quickly permeated many other languages. Okay. And I did want to, I guess one other little thing, I always remember Rob McFarlane, who I think was just here a little while ago, saying that when the way he thinks about writing is that each chapter is a short story and the whole thing is a novel. So I tried these themes weave in and out, but as you say, each one is kind of a self-contained episode. And again, with these founders and pioneers, the most humbling thing about them is that they were asking the same questions that we ask today. Why is there a volcano here? Why does it erupt now and not in 2 weeks? And why is it erupting in this particular way? And when is it going to stop? What's the source of energy? Yes. We're still asking those questions, and we're still drawing schematic cartoons in our scientific papers that look like the kids' drawings.
I think it's wonderful. It sort of keeps that sort of history of childhood going. But then, there are other figures, William Hamilton, when he was the ambassador to Sicily. Of course, Sir William Hamilton was, of course, the husband of Emma Hamilton, Horatio Nelson's other half, let's say. And I think one of the things that came out very much within the story of, his observations of Vesuvius, I think it was, wasn't it, right the way through his ambassadorship, is just the quality and the detail of the repeat observations. And that's a thread that I think follows you through into your own career and some of the others that you talk about within there. But I want to sort of pick up on, there's one person who seems to be, I think he's in sort of almost every other chapter of the book, which is the American Frank Perret, who, I don't know if anybody in the room has heard of this gentleman, but he seems to have been really one of the key figures that certainly you seem to have a real affinity for. Can you tell us a little bit more about this man and what he did?
Yeah, Frank Perret. So he was born late 19th century in New York, and he went to college to study engineering, but dropped out to work for Thomas Edison. And he was designing elevators, as they're called in New York, I guess, and battery technologies. And he left Edison and set up his own business. He designed an electric car, a little bit early for market.
Wow.
And but he had a breakdown, and he was convalescing at home in his 30s when the newspaper arrived, and catastrophe. It was the disaster of Montagne Palais in 1902 in the Caribbean, and 26,000 people had been killed in a volcanic eruption. This was a very bustling commercial center in the French Caribbean. And he looked at this and he said, I'm going to devote the rest of my life to studying volcanoes to prevent another disaster like this.
Yes.
And so around the same time, his doctor says, the best thing for you, Frank, is to go somewhere warm to really get over this. Somewhere like Naples. That'll do. So he goes off to Naples and he befriends the director of the Volcano Observatory. And Vesuvius is ramping up to a very major eruption.
Yes. And
Perret is very closely observed in the observations and advising the authorities on evacuations and so on. And he's got this know-how to make things. And he made seismoscopes, he made gas sensors, he'd rip hearing aids apart and stick them on a gramophone horn and put it on the ground. He would bite the metal bedstead of his bed to amplify seismic vibrations in his skull. So, real empiricist.
Please tell me these are things that you've also repeated in his footsteps.
Naturally. Yeah. So he was the real deal, but he after Italy, he wrote a marvelous monograph on the eruption. But he then traveled. He worked on Etna. He went to Japan to work at Sakurajima. He helped to establish the first volcano observatory in the US at Hawaii with the geologist Thomas Jagger. And then he was, Montagne Palais came back to life. So he was in the Caribbean, fate really demanded that he should show up there, and he put his built a cabin right at the edge of the valley where these lethal pyroclastic flows were racing down. He was engulfed in the fringes of one at one point, which had him in hospital for a bit. And then he was on Montserrat, the neighboring island under British administration. And he wrote these extraordinary monographs. He was modeling and interpreting and interfacing with the people, with the communities, with the authorities and decision makers. He really did devote his whole life to the volcano.
Yeah, there are certainly sections, and I think we'll talk about his experience with Montagne Pelée in a moment, that you just sit there going, how on earth did he survive the length of time that he did, with the experiences that he had?
I think it's how did he survive the horse serum that they injected with him after the exposure to these volcanic gases. I thought the treatment sounded worse than the...
And I think sort of taking on that theme of field observation, I think there's an awful lot of work, as you were saying, in the light of the COVID sort of pandemic and the lockdowns and all of the significance that was placed on modelling within there. But of course, you've talked just there about the equipment that Perret generated and built, and there's a fabulous photograph, I think, at the start of the chapter on him with the big hearing horn and the hearing aid, trying to listen to the volcano. And of course, you're a field scientist. I think you make a very strong case for the field observations that you've taken. In many ways, actually, also sort of grounded in terms of just looking at these things out of curiosity. And we'll come back to the science a little bit later on. But just tell us all in terms of the benefit of what do the field observations tell us? What do you collect in the field? And what does that enable us to learn about the volcano itself? Because I think we're in an era where we see images from space or remotely sensed imagery. We see these big, large-scale things, and it seems almost impossible to think, how do you scale that down to one person on the side of a volcano looking over the rim of the caldera? What is that data that you're collecting, and how does that help us understand what's going on?
So a satellite can't collect a rock. We instrument volcanoes with seismometers. I spend a lot of my time measuring gas emissions from volcanoes with different kinds of spectrometers and other sensors. We look at the changing shape of the ground as molten rock rises in the crust. That will deform the surface, and that can be picked up by GPS and from space. So, I mean, a lot of those observations are really trying to help us imagine what's down there. I can't remember if I reflect on this in the book, but it's something that, geologists, we're a strange breed because we think about time in a completely different way. I guess that's sort of well known, that 10,000 years is sort of nothing to us. Yes. But we also think about space in a very different way. And we imagine a region inside the Earth that we will never see, we will never touch it. And we can only make an imagination of it based on these observations. So those observations need to be collected as carefully as possible.
Yes.
And so, I mean, a theme is about observation. And if we go back to the late 18th, 19th century, there was this big argument between rationalists and empiricists. And I would say that's, it's played out during my own career. I've made careful observations, and I've had colleagues who've said, yeah, but where's the model? Where's the model? And, I can turn around and point to some modeling works. You've got a lovely model here, and you've taken some data from the literature. And I notice that one of your examples is an eruption in Scotland. When was an eruption in Scotland? Any time in the last, millions of years. And they'd just taken, it was a bit of ash that had been found in some peat in Scotland, and they just assumed that was an instance of a volcanic eruption in Scotland. So I think, observers need to work with modelers. We need to put all of this together. But those careful observations are revealing what's going on in the underworld. And the rocks now we can measure them at the nanoscale. So I've had projects where we've used the UK's synchrotron facility, a big particle collider, and because you have such phenomenal energies of X-rays, you can look at the most minuscule concentrations of elements in an inclusion in a crystal, in a piece of pumice, and leverage on that chemistry to say something about where was that molten rock in the Earth's crust and how was it, what triggered the eruption. So there are lots of things that we can do.
That sounds phenomenal. You can look at something at a nanoscale and then assume this is how the volcano is operating, this is what the magma is doing beneath that. So of course that means that you must be using phenomenally complex equipment that's cost millions of pounds to build, yes?
No, not exactly, no. We made a lot of, I'd say typically what we would do is buy available commercial products. So we would, for example, one of the things was a very small ultraviolet spectrometer. Sulfur dioxide gas is one of the trace gases that leaks out of volcanoes. It's very diagnostic of where the magma is and is it on the move.
Yes.
And it absorbs ultraviolet radiation. So the clouds of gas traveling overhead, if you look at the blue sky, you can see if there's sulfur dioxide, it will absorb some of the light. So we use these things, but we needed to hook them up to telescopes. We bought a lot of drain pipe and made our own telescopes. We then tried to see how we could use them. We wanted to put them in scanners, so we would just buy components from Radio Shack or whatever. There was one piece of kit, we built a radar from scratch, a very bespoke device because there was nothing off the shelf that would do what we wanted to do. But yeah, pretty Heath Robinson.
I was just thinking it's all held together with string and duct tape, isn't it?
Yeah, Blue Peter stuff. Yeah.
So it's really interesting in terms of the quality of that data that you've collected over the years. Do we still need that sort of field work?
I think we do. I mean, there is, when your eruption gets, big scale,
yeah.
Then you're not really on the ground anymore, and maybe the pyroclastic currents have taken out your sensors on the ground. And then we do need the view from orbit, and what the capabilities of satellites are really good at that big scale. And
yes.
If we want to know where is the ash cloud traveling and where might it intersect aviation corridors, we can't do that effectively from the ground. We need that synoptic view. But if we think about the gas emissions that I measure, they're too weak to see from orbit. You've got to look through the whole atmosphere. There are a lot of other gases that are in the way, and you won't pick up this little trace signal. So you need sensors on the ground to be able to do that.
Okay.
And I mean, I have colleagues who are working with drones to fly sensors in. A lot of my work has been on volcanoes that are not too dangerous, but they're erupting. Often with lava lakes,
yes.
Because when you have a lava lake, it's the top part of a magma system that will extend many kilometers below the surface. So we can make direct observations of the magma and infer what's going on deeper down.
I love the idea that you refer to that as a less dangerous volcano.
It's relative. It's relative.
And thinking of those dangers, I think one of the things that we often think of as when we're drawing a volcano as a child, you think of the lava flows, the pyroclastic bombs, but certainly something that comes out in numerous chapters within the book are these flows. Is it Nue Ardente or Ardente? I don't know how you're supposed to pronounce it. I keep meaning to ask you about this. What are these things? Because these seem to be the ones that are responsible for the majority of the deaths that you talk about in terms of some of the disasters within there. What is it about them that is so hazardous, so dangerous?
Yes, and if we look from the beginning of the 20th century, most of the fatalities in volcanic eruptions have been from Nue Ardente.
There we are.
I don't know. There's now probably much better French speakers in the audience. Pyroclastic currents, pyroclastic flows. And mud flows. So these are gravity, they're driven by the force of gravity. They'll follow the topography in a volcano. They move quickly and they can reach great distances, so they can reach settled areas. If we go further back in time, actually, there have also been a lot of fatalities from famine. The famine that has followed the destruction of crops by the fallout of ash. So that's something that we haven't seen so much of in the modern period. It doesn't mean it's not a problem.
Yes.
going forward. But the pyroclastic flows, and just an aside, I mean, most of volcanology is about fluids. Okay, it's about the molten rock below the ground. It's about how that erupts at the vent, and the cloud of ash that travels through the atmosphere is a fluid. The lava flow is a fluid, and the pyroclastic flow, it behaves as a fluid, even though it's made of chunks of pumice, gas, dust, big chunks of rock that have been ripped out of the throat of the volcano. So these are very hot, 300-400 degrees Celsius. They can move 50, 70 kilometers an hour, and they can have very considerable vertical extent, and the denser parts might sort of congregate around the bottom. That's very destructive just in terms of the brute force of anything it impacts. That it's hot enough to ignite vegetation, things in the built environment.
Yes.
But they also have this considerable vertical extent. The finer dust is billowing upwards, and that can also have a life of its own. It can even overtop a valley and go into a neighboring valley.
Gosh.
And it's called flow stripping. So the flow is headed this way, but a bit of it comes over here in an unexpected direction. And as I say, their temperature, the debris, the brute force, the dynamic pressure that they have is very, very destructive in the built environment. Very low survivability for people caught out in the open.
And again, going back to Frank Perret, his hut was affected by one of these flows, wasn't it? And that was where he got the horse serum as a consequence of.
That's right. Yes. No. He even. I mean, he wrote. He even as he's wondering, are these my last breaths? He's trying to figure out, can he detect hydrogen chloride or sulfur dioxide in the gas, and he concludes no. Maybe there's a bit of carbon monoxide or something.
Yeah. Good grief. It's crazy, man. And I think, sort of moving on from, I suppose, the science, because that is a major theme throughout the book, is the scientific work that you've done. And I think, one thing, if we had more time, I'd really want to talk, get your sense of the prediction of volcanic eruptions, because I know there's some reference made to Darwin, his early observations, that you've sort of subsequently sort of been able to say, actually, yes, there is a pulsing, but in a very different way than he said. But I think moving on to talk about a little bit of the cultural sort of references that you make within the book, because something that I think is fascinating within all of the earth and environmental disciplines is that the bits that are the most interesting are often at the boundaries between those disciplines. You talk about the connections with anthropology, glaciology, with climatologists and all those sorts of things. But you really, really strongly pick, with all of the stories that you tell in each chapter, you pick up some of the cultural references and the cultural significance. And I think, the one that I'd particularly like to ask you is one that fascinates me, because I know I'll probably never get to go and visit it, which is Paektu in North Korea, the volcanoes in North Korea. Can you just sort of give a little bit of the story of why this volcano is seen as such a spiritual site, as well as a politically significant site as well?
Yes, I'd never expected to go to North Korea, but volcanologists are aware of a volcano called Paektu by the Koreans, or Changbaishan in China. It's on the border between North Korea and China. And we know of it because of the Millennium eruption. Around 1,000 years ago, there was a colossal eruption which hadn't hitherto been dated, but one of the largest of the last 2,000 years. And after the Tohoku earthquake in Japan, there was a lot of concern about whether a large explosion could destabilize a nuclear facility, or vice versa, whether a nuclear test could destabilize a volcano. And so there's some sort of scurrilous content in the web at the time. And the Koreans, there'd also been an episode of unrest between about 2002 and 2005 at the volcano. Lots of earthquakes were being detected. And the Chinese put a lot of money into monitoring. The North Koreans recognized that they didn't have the expertise, and they reached out. They found me somehow through various connections, and I went out to Pyongyang, knowing that this volcano, had some significance for volcanology, but completely unprepared to discover its cultural significance. So the first thing we did was to go to the grand statue then of Kim Il-sung, and behind him is the volcano, a huge mosaic. Within 24 hours, we're at the military parade with all the weaponry and tanks and what have you, and I don't know, 50,000 human pixels with placards making images of the volcano. The volcano, why is it so significant? And when we went up there, we saw hundreds and hundreds of pilgrims going up to the summit. You can even take a cable car down into the floor of the crater where there's a big lake. And for the North Koreans, it's the sacred mountain of the revolution. So Kim Il-sung was said to have fought against Japanese occupation from his secret camp on the side of Paektu. So the North Koreans identify this revolutionary fervor. But in a way, this is appropriating a much deeper ancestor story about the volcano, that it's where the Korean people came from. So in South Korea, as well as North Korea, the name Paektu is sung in the national anthem. When Moon Jae-in, president of South Korea, went to North Korea, he met Kim Jong-un at the edge of the crater.
Gosh.
And the symbolism of this, if this volcano for reunification is very, very strong.
Gosh, I can imagine the shock at actually sort of going out as a scientist and then going, oh gosh, actually there's a very, very different story here. And in terms of the sensitivities of working somewhere like North Korea, and it must have been challenging in terms of the equipment that you were using, the ideas even that you were sharing. To what extent were North Korean sort of colleagues able to access the literature and the background information that you were working upon?
Yes, I would say the communication gaps were very, very substantial. I mean, first of all, I don't speak Korean, and everything went through interpreters, and so that's one thing. But as you say, they don't go to the international conferences. They don't have access to the internet. They don't get the papers. So while they're very well trained in the fundamentals of geophysics, the mathematical side of it, much better than I, yes. They're not at the cutting edge of something like volcanology, which is really quite touchy-feely. We interface a lot with the social sciences, particularly when it comes to protecting populations from eruptions. The monitoring is part of it. You need to interface any kind of decision-making about evacuations with risk perception, risk tolerance, preparedness, and so on. So they didn't get any of that. And it was, we went in 2011. As you say, it's under the most strict sanctions, international yes. sanctions, even sharing knowledge. We've worked with the UN to ensure that we're sanctions compliant. And when sanctions have got stricter, we've found exemptions to continue our exchanges, which have included the North Koreans coming to the UK for periods of time to work up data and write papers.
Oh, wow. It just shows how important that collaboration is, isn't it, even across those political divides. You just started touching upon one of the last questions I wanted to sort of feed into before we start pulling the audience in to ask some questions. And that's about the importance of prediction, being able to predict what's happening. Because, of course, so much of the drive for the research that you've done and the stories that you tell within every chapter of the book are often about the imminence of a hazard, the imminence of a threat, and the concerns about, well, what's going to happen. And I think there's a number of characters that you talk about. And I think, is it Harun Tazieff that you talk about, who actually became quite controversial in the way that they were either overplaying or underplaying the hazards associated with a single volcano, often against the judgment of other bodies within there. So my question, I suppose, is to what extent can we predict the type of behaviour? I'm kind of thinking with half a mind on what's happening in Iceland at the moment in terms of how imminent these sort of eruptions are before we can be confident in saying it's going to happen.
Larger eruptions won't happen without warning if you've got the sensors on the mountain. A very, very well-oiled volcano that's sort of erupting a lot, maybe a modest eruption, will be harder to pick up.
Yes.
So if you have the sensors, seismology, measuring earthquakes, geodesy, measuring the uplift of the ground, gas sensors, looking at the cocktail of gases that emerge. This is all giving you information about where the magma is it on the rise, how much is down there. So it's possible to do a lot with that.
Yes.
And Iceland is one of the places where they have tremendous experience, tremendous assets, very close cooperation of the scientists at the Met Office and the university with emergency planners, civil defense authorities. But even then, I haven't checked. Someone will say, "Oh, it's erupted. You just haven't looked at your Twitter feed." But in Iceland now, it's still unknown. I mean, there's a lot of magma is on the move, but will it stall in the crust? So this is one of the big problems that we face. The signs that a volcano is coming to life, is rumbling. We call it volcanic unrest. Those signs, we can pick those up. Discriminating which of those episodes of unrest will culminate in an eruption rather than the volcano going back to sleep is very, very difficult.
Yes.
And it's actually easier somewhere like Iceland than it is on many of the volcanoes around, for example, the Pacific Ring of Fire, these more explosive systems. Maybe on average, 9 times out of 10, the volcano will go back to sleep. Mm-hmm. Do you evacuate 500,000 people when you have that kind of scientific uncertainty? That's a very weighty decision. Yes. On somebody's shoulders to make so much disruption of people's lives and livelihoods.
Yes, no, I can imagine it's not something I'd want to have to make the call on. And so I'm just conscious that we're coming towards the end of sort of being able to talk about the book before we open out to the audience. The final chapter, or the final main chapter of the book, is about Erebus, a mountain that, well, we were joking just coming in, probably loads of people in this room have been to. Erebus is, in Antarctica. It's one of the most, inaccessible locations on the planet. And given that the book is about the stories, the cultural significance of these, in Antarctica, of course, we don't have the populations or the long-term permanent populations there to sort of build up those myths and stories. But I think you said, and I'll just quote it here, that you call Erebus the most sublime and imposing sight that you've ever witnessed and that you've ever seen. What is it about Erebus that makes it so special to you? Because it's the volcano that you spent the longest time at, isn't it?
Yes, it is. I went every year for 13 field seasons with the US Antarctic program.
Wow.
And it would be nuts to do that, except that Erebus is about 35 kilometers from the largest scientific base in Antarctica. So with a lot of logistical support, helicopter support, we have a field camp 3,500 meters up. But what made it so special is, firstly, the setting is indescribably beautiful. The views from that height on a clear day across the Ross Ice Shelf to the Transantarctic Mountains, over 4,000 meters, the glaciers streaming off them, the sun never setting, just doing this big circle in the sky, and the light changing, the sea ice breaking up in these wonderful big polygons, the lava lake in the crater, this very dynamic, bubbling lake of lava that you can't take your eyes off when you're up there, ice caves, where the warm gases are leaking out from the flanks of the volcano. There are ice caves with extraordinary crystal formations and ice stalactites and stalagmites. So there's all the spectacle of it, and this being in this very cold, very, very dry air, and stepping off the helicopter with your extreme weather clothing, feeling like you're an astronaut climbing onto the surface of Mars. There's all of that. There's the science. It was the most rewarding science for me because we could make very careful observations of this lava lake. And it didn't, it tantalized us and tempted us with its secrets from the measurements. So that was wonderful. But it was also just being in a community of 10 people.
Yes.
Under canvas. We had 2 permanent huts, so we were comfortable, but we slept under the canvas. And knowing that actually you've got even with the base only 35 kilometers away, with potentially sometimes a week of blizzards coming through, if something goes wrong, medical emergency, there's no way anyone's coming in.
Yeah.
And so you feel that fragility to being up there. And I think just that sense of community as well. A lot of my other field work has been very, exciting, but I've stayed in a hotel in the evenings. I've had a nice
Sounds
pizza.
perfect.
This was very, very, very real out there, and I loved every moment of it. And I actually thought I could read you page 250 in there, or you could read it if you like, because I originally planned to end the book with Erebus, and in the end I wrote another chapter, which is all about the volcano in you, rather than volcano in other people. But Shackleton wrote a poem about Erebus, and he wrote this: "With icefield, cape, and mountain height, flame rose in a sea of gold. O herald of returning suns to the waiting lands below, beacon to their home-seeking feet, far across the southern snow. In the Northland, in the years to be, pale winter's first white sign will turn again their thoughts to thee, and the glamour that is thine." And I think you have to have been there to know what he meant, because if I see the light in winter and the frost is there and it's a very low light, I think of Erebus, and it takes me back. It never leaves you. Yeah, never leaves you.
It sounds absolutely incredible, and it's. I'm sure there's probably one or more people in the room who've been to Erebus, but I think
if there's any audience where there's, yeah, I've been, it's this one.
Regularly. But, so just to end then, because hopefully everybody in the room will be inspired, first of all, to buy the book and hopefully get it signed afterwards. But I often think, I do lots of trips into schools where children start drawing volcanoes, but they're distant. They're not something that we have in the British Isles. They're far off destinations. You have to travel out to them. So where could somebody from the audience within here, somebody who's been inspired from you today, where could they go to get some of that sense of inspiration, having sat through this in the Mountain Festival?
Well, we've got a lot in the UK, and we've got a lot right here, of course, in the Lake District, the Borrowdale Volcanic Group, Windermere Group, and even the culture. I mean, these Langdale axes that were made, these prehistoric, beautiful stone axes made of the volcanic rock. And these, of course, they're a few 100 million years old, but actually that's revealed the roots of volcanoes and the structure that's very difficult to see on an active volcano. I went to the Giant's Causeway for the first time a few months ago. I thought it was fantastic. There's a lot in the UK, Glencoe in Scotland. And of course, if you want to go a bit further afield, Italy, Vesuvius, Pompeii is extraordinary. You look at it, you see the ancient city, but you see how people lived and how sophisticated their lives were and the things that they had, and you realize you're looking in the mirror into the past in these excavations. Etna, Stromboli, and of course Iceland. So there's a lot. The Canary Islands, they're all volcanic, and there's a big movement now of geoparks. The Lake District has World Heritage status. There are a lot of World Heritage sites that have volcanic terrain that's part of their statement. So this geoheritage movement, geoparks movement, is really taking off, and that's not just about volcanoes. It's about why do we have Cambrian and Devonian and Silurian? That all links to parts of the world, mining heritage. There's a lot that you can explore actually, and link the geoscience to the culture, to the landscape, and it's available right here beneath our feet.
So hopefully, if the weather's decent tomorrow, one of your opportunities is to head out from there. So thank you, Clive. That's been an absolute joy. I've really enjoyed that. I could go on for days on this one, but I think it's only fair. We have about 10 minutes to open up the floor to questions of Clive. So there we are, some lights appearing here. So if you want to, please sort of pick up your hand and sort of, yes, you in the front here.
How are we using our knowledge and science of our study of volcanoes on this planet to understand volcanoes in other parts of our solar system?
So the question was how do we use what we know about studying volcanoes on Earth to study understanding of volcanoes elsewhere in the solar system? I'd add to your question and exoplanets in other solar systems. So I'd say, I mean, a lot of it is about chemistry and physics and fluids, the mathematics of fluids. And so there's basalt. Basalt is the most common rock at the surface of the Earth. There's an awful lot of it on the sea floor. Basalt covers Venus. Basalt covers Mars. So we can infer quite a lot from looking at the planetary images. We have to factor in that the force of gravity is different. That means that's one of the little g goes in the equations for how fluids move around. The atmospheric pressure makes a big difference. So when a volcano erupts on the seabed, under 2 kilometers of water, it's going to behave differently to if it's at the surface of the Earth. And it'll behave differently if it's in the crushing atmosphere of Venus or the very thin atmosphere of Mars. So we take, I guess, a lot of the knowledge we have from the Earth, but also we need to take in what are the external and internal influences that will be playing out in different planets and moons. The most volcanic body in the solar system is Io, a moon of Jupiter. And there's a lot of interest in exoplanets. Could we detect from the spectra of their atmospheres, could we detect whether there's ongoing volcanism from the chemistry of the atmospheres? So, yeah, I think there's a lot that we can. Comparative planetology goes both ways. What can we learn about the Earth from studying Venus? What can we learn about Venus from studying the Earth?
Thank you. Any other questions? I can see there's a hand up over there somewhere. Yeah.
There's one at the back.
Have you had the opportunity to study or even visit any of the underwater volcanoes?
So have I been able to study any of the underwater volcanoes? I haven't, no. I mean, I know 1 or 2 people who've been in these submersibles and have been down to some of these oceanic ridges. And that would be quite something to see. No, absolutely. I wouldn't mind that. But I guess, I mean, what I've seen is some of the products of submarine volcanism when it's been exposed. One of the, I think there might even be some actually in the Lake District. They're called pillow lavas. So lava that erupts underwater, it will squeeze out like toothpaste being squashed out of a tube, and it piles up, and it leaves these very distinctive. I don't really know why they're called pillows rather than toothpaste, but anyway, it's a distinctive landform. That's the nearest I've been to, I guess, to a submarine volcano, seeing some of these rocks.
I always loved hearing the terminology of different types of lavas, when you're and pahoi hoi, and I like the idea of being the sharp stuff that would hurt as you walk over it. So, any other questions? I can see somebody hand up at the back over there.
There's another one.
One of the biggest volcanoes in the last couple of years has been the undersea volcano of Tonga. For size, it seems to have been relatively overlooked in the media. Just say a little bit about the significance of Tonga.
Yes, that's great. So Hunga Tonga erupted in January last year, and it hit the news because there was a lot of it had cut the communications. Nobody really knew what might have happened. It was very likely tsunami would have happened with this submarine eruption, and fortunately, most people had gone inland and escaped the ravages of the tsunami. I'd say that the sort of big scientific story that emerged is that it was a large eruption, and the plume went very high up into the stratosphere. I think it's the highest plume that's been detected in the instrumental era, with satellites looking down, bit of particulate, and the impacts on volcanoes on the atmosphere. They can have impacts on ozone chemistry, but also the sulfur gases form particles that can reflect a bit of sunlight back into space and lead to a cooling at the surface. And Tonga didn't do this. It had very little sulfur went up. So it hasn't had a cooling effect. But it took a lot of seawater and put a lot of water vapor into the middle atmosphere. And that it's a greenhouse gas. It's had a very, probably had a slight warming effect. So this exceptional warming in 2023, a little bit of that is El Nino, and possibly a very small fraction of it is Tonga. So there is a great deal of interest in it from atmospheric scientists, the remote sensing community, not least because actually most of these observations are spaceborne observations with some of the very sophisticated satellite sensors that are up there now. I think we had one, there was one.
You mentioned at the start and talk about your naivety when you went to Stromboli. What happened?
What did I get up to on Stromboli? So within a month of starting my PhD at the Open University, I was out on Stromboli, and I had two supervisors. One, the volcanologist, actually was in the States, so I didn't see him for a year. The other one was a satellite remote sensing specialist. It was actually me who said, do we need to take a gas mask or a helmet or anything like that? Yeah, okay. And he came out with his wife and had a little bit of vacation and then left me. And the volcano Stromboli got a lot more active, but we were up at the top, and I was at the edge of the crater. It's insanity. You would never, ever do this with an infrared thermometer pointing and trying to measure temperatures of the vent, which is erupting. And it's exploding, and these rocks are flying out. And I got really quite anxious because I'm even seeing this telescopically through the viewfinder, and I'm starting the longer since the last explosion. I'm really now anticipating, and one rock landed just over there. I'll have that. Very hot. Which if you're there at night time, they're red hot. So that was trying to shake basalt off your fingers. It was a steep learning curve, and after a few more hours of this and these rocks, I really thought, well, if one of these hits me, that's really bad news. And it took me sort of 24 hours up there to realise that this wasn't sensible, and it was really not sensible at all.
It is fascinating, though, isn't it? Because you sit there early on in your PhD, desperate. I've got to get this data, and it was really telling when you said after a few more hours of this.
Well, there's this is again, you write a paper. I don't know if it's even a chapter in the PhD, but there's a little bit of one scientific paper where I talk about these measurements. So the idea was, could we measure accurately the temperature of this vent from space with infrared satellite images? And so I was collecting ground truth, measure the temperature, compare it with what we can calculate from the satellite image. And of course, the temperature is changing every second because it's so dynamic. So there's one little graph in one paper, and I don't know if anyone would have stopped in reading these data were collected at a distance of 50 meters. If anyone stopped to think what that actually meant, proximity. But I mean, 3 people have ever cited that work, so it wasn't worthwhile.
Oh, but it was at the time. I think we have time for one more question. Is there one? Just seeing, can't see one over there. Let's go for you at the front here, sir.
Is there a volcano out there that you're particularly afraid of in terms of humanity? Obviously, there's the supervolcano that was talked about in Yellowstone, but is there one that you think stands out as a particular threat to, a high populous area, something like that, that's on your radar that's caused mass destruction in close, relatively soon?
So the question is, should I go on holiday to Naples, I think? Where's the worst volcano in the sort of relatively near time frame? I don't know, and I think it's entirely possible that the next really big eruption will be a volcano I've never heard of. And that's partly just looking at the last 50 years, some of the biggest eruptions: El Chichon in Mexico, 1982, Pinatubo, biggest eruption in over 100 years in the Philippines, 91, Chaitén in Chile, 2008. These were volcanoes not on the radar, not on the scientific radar. They hadn't done anything for centuries or millennia, and so they tend not. Some of those don't get much attention. Somewhere like Chile, which has dozens and dozens of volcanoes, limited resources. Well, we'll monitor these ones; they're active. The one that's a sleeping giant that might come to life. Do you put assets on that when it's not going to do anything? So I would say, yeah, it might be the next supervolcano, probably somewhere I've never heard of, and will struggle to pronounce as much as I do Eyjafjallajökull.
Well, that's fabulous. We're now out of time for that. I hope you'll join me in thanking Clive for what's been a really, really fascinating discussion. Thank you. Thank you, Clive. That's been great. Wow, almost a standing ovation there. Thank you so much on behalf of Kendal Mountain Festival. Thank you on behalf of Cotswold Outdoor as the sponsor for this. As we mentioned at the beginning, there is going to be a book signing at the back of the room after this, and I'm sure Clive will be happy to answer many more questions. But thank you very, very much. It's been a fabulous audience.